Hey, what's happening, guys? Today, we are going to build a Velleman kit, and Velleman makes some of the best kits in the world. This one is a stroboscope, AC powered, soldering required, 2 to 20 hertz, difficulty of 2. I received this kit yesterday from my friend in Germany, Vim, and quite serendipitous. He didn't know when he ordered it that it would be delivered on my birthday, and it was, so that was very cool. Dankeschön, Vim. Now here's the reason why Velleman kits are just outstanding. The documentation. Velleman kit skill level 3. Easy to build stroboscope for general application. Now, this says 2 to 20 hertz. This says 5 to 15. Interesting. We'll see. Power consumption 13 watts. Alright, what should we got here? Start with the resistors. Got a diac. There we go. There's our circuit diagram. Alright, so let's have a look here. So we've got live and neutral. Live's coming in, going through a diode. Coming off here, going through charging this capacitor and this capacitor. Resistor, there's our flash adjust. Got an inductor here. Okay, there's our diac. So this resistor and this resistor making a voltage divider, controlling the charge rate of this capacitor, which is going to fire the diac to control the triac. This resistor divider here is going to provide a steady voltage, depending on where this voltage is, into the inductor and fire the flash tube. So, let's have a look at our parts here. We've got a very long potentiometer, 470K. That's to keep your fingers away from the live voltage, I'm sure. We've got a 5 watt 330 ohm power resistor. That is a capacitor. .22 microfarad, 350 volt. Those are some big capacitors. .22 microfarad, 350. There is our inductor. PC board. Resistors and diodes. Another capacitor. This one is 10 microfarad, 50 volt. This must be our diac. This will be our triac. All right. Let me get this stuff out of here and get organized, and we'll get to building. All right, let's get started building. Number one, resistors, R1 to R3 are 100K. Let's just test one of them to be certain. Never hurts to test something out to make sure it is what you expect it to be. Avoids nasty surprises later on. Yep. So R2, here's R1. Next we'll do R2. It doesn't matter. I could have put R3 in first. Like I said, it doesn't matter. I'm just doing them in order. R3. Resistors are not polarized. That means they could go in either way. But conventional wisdom says that we put all our resistors facing the same direction. So we have our tolerance bands all facing down here. Alright, let's zoom in here so you can get a better view. My soldering iron is set for 340 degrees. And we just got to give it a second to come up to temperature. And we'll be ready to roll. These are nice big pads. So this would make for a great beginner's kit. But you have to keep in mind that this is a mains powered kit. And with that trigger coil, that inductor, you know, we're probably looking at kilovolts to fire that flash tube. And that's no joke. That will speed up your existence on Earth considerably. So if you build a kit like this kit, any other kit that is mains powered or do any sort of mains powered electronic experimentation, do some research, get some education, protect yourself, protect those around you. Because, you know, you don't want to be dying too soon. All right, next up is our diac. Looks kind of like a diode, but they are unpolarized. And the diac will be the trigger for the triac. If you don't know what I'm talking about, you can check out my basic electricity and electronics playlist, where we've gone over diacs and triacs. If you've ever used a dimmable mains powered light in your house, you've used the diac and a triac. Good. These are nice components in these Velleman kits, way better than any of the dirt cheap stuff that we normally get from the Far East. Okay, so we did our resistors. We did our diac. That's the first page of the instructions done. What do we got next? Who's next? Who's next? Diodes D2 and D3. Diodes are polarized, so we must be careful with them. And you'll see the diode footprints have a wide band on one end. That is the cathode end. And you just want to match that up to the band on the diodes. Diodes are like electrical check valves. They will only allow current to flow in one direction for the most part. There are exceptions to that. If you greatly overpower them, they will reach what's known as their breakdown voltage, and they will start reverse conduction. And then there are some diodes that are designed for reverse conduction, such as a Zener diode. Again, all this kind of stuff is covered in my basic electricity and electronics playlists. So if you're unfamiliar with this, you can find out more information about it there. Also, this video is sponsored by Solderstick, and we'll talk more about them in a little bit. But they make all sorts of great connectors And one of the neatest ones we'll talk about in this video are their insulation displacement connectors. Something just fell off my desk. Now if you take a look there, you see how those joints look like little Hershey's Kisses, little mountain tops? That's what you want. Shiny Hershey's Kisses. If they're dull, like a dull gray, or they look like an apple, that's not a good solder joint. So, like I said, yesterday was my birthday. What did I do for my birthday? Well, my family's mostly gone now. Blake's away at college. So, I have two aunts. Well, I have one aunt and one great aunt. My great aunt is in a nursing home. So, my aunt picked me up. We went and had lunch with my great aunt in the nursing home. That was what we did for my birthday. Okay, who's next? R4 is the high power 300 ohm 5 watt resistor. Now, that guy goes right here. Bend these legs down. And I'm going to use this nut here as a spacer. This resistor is going to get very hot. And we don't want it to burn on the board. This is a trick I learned from doing amplifier work. See how I keep that off the board just like that? That allows a little air to get under there, a little circulation, and you're good to go. Now, make sure you take that out. We don't want any extraneous metal in there causing us some problems. So, what did I get for my birthday? Yeah, in my family, it is a tradition for the birthday. You get a number of dollars equal to how old you are. So, I made over $100 from two people. I know, I'm getting old. All right, next we have the 0.1 microfarad 400 volt capacitor. That's this guy here. These are not polarized, but I'm going to put it in this direction. And I'll show you why in a second. Oh, and it fell out. These are big pads on here, so it's going to take a little bit more solder than you're probably used to when doing the smaller kits. So just, plan for that accordingly. So yeah, I haven't seen my son yet for my birthday. He'll be home this weekend. We'll see what he gets me for my birthday. Should be interesting. Okay, next we have the 10 microfarad electrolytic capacitor. That's this guy here. You go back there. They are polarized. See that line? That line is the negative, and the long leg is generally positive, so we'll just put that in there like so. We'll get it soldered up. I think this would be a fun kit to play with. I have some ideas for it, what I might like to do with it. Okay, so now we do J1, which is where we will put in our mains voltage. And if you've been paying attention to how these things have gone on, we have started with the smallest components, the resistors, the diodes, and we've moved up to the larger components. That's so you don't have to be reaching down around the larger components to solder in smaller components. Okay. Next is the trigger coil. I'm just looking to see if there's any labeling on this thing, and I don't see any. So we will go with the way that these legs are splayed out, like 90 degrees apart. And that looks like it'll fit here perfectly. Like so. And we'll get that guy soldered in. So if I wasn't talking to you and, moving things around and filming, this kit would probably take me about 15 minutes. So it's a really nice, easy little kit. But again, you've got that mains voltage thing there. That can be quite dangerous. All right, what do we got next? The big caps. 22 microfarad, 350 volts. These will be filter caps. So, Blake called me yesterday. He's starting his second semester up at Pitt. And one of the classes that he scheduled for this semester was archaeology. And he was very excited. He called me to tell me that the professor's name is Dr. Tekla Schmaltz. I'm like, wow. That sounds like a very, very German name. He's like, I don't know, she's from Chicago. Well, she could be a German from Chicago, Blake. But anyway, he is very excited about that class because they are going to finish up the semester with projects at local cemeteries. And, he's a teenager, so he thinks that's interesting. Who knows? He may switch from physics to archaeology. He said she did start off the class with a joke. She said, if you're here for dinosaurs, you're 65 million years too late, and that would be paleontology anyway, not archaeology. He quite enjoyed that, as opposed to his second physics class. He said where the professor came in, he says, hello, I am Professor Solomon. He goes, I've been teaching here for 14 years. I don't curve. There is no curve. The grade is your grade. Do not ask me to curve. So Blake said, I don't think he's going to curve the grades. Yeah. That's up to the professor. So it's always interesting to see, the different personalities of the educators. And I told Blake when he first went away to school, I'm like, you're going to find all different types of professors. So what's he have today? I think today he has like the history of film or something that he took just because he needed another credit hour for full-time status. Okay, so we're almost done here. Next up is the triac. And it says the writing on the triac, the label, the front side, should face R2, which is that resistor right in there. Come on, get in the hole. There we go. That is not a good footprint for this component. Like, I'm forced to really shove it in there and kind of torque it a bit. They should have just went with a 3-in-line footprint. You know, just plain old TO220 footprint would have been fine. So far, that's my only gripe about this kit. All right. And that leaves us with just... cut that one a little low. If that happens, what you want to do is just kind of come back in and reflow them a little bit. Make sure everything is hunky-dory. And that leaves the last component, which is the flash tube. Okay, so it says mount the strobo tube marked tube. Check the polarity. The connection marked with a red strip or dot must correspond with the plus on the PCB. Great. I see no red strip or dot. I'm going to take this out into the sunlight and have a look. I'll be back momentarily. All right, so I told you earlier this video was sponsored by Solderstick, and they make all kinds of connectors. One of the coolest types of connectors they make are T-tap connectors, which are also referred to as insulation displacement connectors. We have the red from 22 to 18 gauge, blue from 16 down to 14, and yellow from 12 to 10. The way these work, you see you have two components for each connection. This is what is going to go onto the host wire, and your host wire is going to fit down in between there, and you're going to clamp it on. And once it's clamped on, your other wire will be connected to this spade connector here, and just pops right on there. Connect up. These are excellent for your car, your boat, quick repairs, whatever you need, and I got you a discount. Check down below for the discount code Solderstick. Check them out, guys. I promise you, you'll like them. All right, back to the business at hand. The stroboscope. Well, I can't find a single red mark anywhere on here. So I looked online for pictures. I can't find anything. The best picture I can find is right here. And to my eyes, all right, you see this little band here? That band appears to be facing the inside of the board like this. So that is how we're going to try it. And hopefully it works. If not, it'll probably end up destroying the tube if it doesn't work. My soldering station has once again gone into a power saving, so we gotta wait for it to come back up. Put that in place. What the heck is going on here? There we go. We'll solder our last three connections in here. And I am not going to solder the crap out of these like I normally do. I'm going to make sure there's a good connection. You know, the entire pad is covered in solder, but I'm not going to build up a hole. I did on that one, whether I wanted to or not. Because I'm thinking if I did this wrong, I'm going to have to remove this. But, what can you say? Alright, where are my clippers? Okay, so that's it. Now we need a power source. I've got a polarized 2-conductor plug here. And, whoops, I'm knocking stuff over left and right. I'm going to tin these wires and trim them. Tin and trim. That makes them more manageable. And it ensures that we don't have any careless whiskers. Just put a little solder on the iron for thermal transfer. And then once it starts wicking in there, you just kind of pull both the iron and the solder down the line. And now, because I don't want 3/4 of an inch of mains live wiring sticking out anywhere, we'll just trim them down. Like so. Alrighty then. There's our board. So in the US, black is live, white is neutral. Those feel like they've been, whoops, closed up. Got a screwdriver here. I could actually cut off another 1/16 of an inch probably, but I'm not going to worry about it. When I plug this in, it will be plugged into a power strip. And I will only be touching it with one hand. I'm trying to make sure I'll be able to adjust this thing. Looks like I can. Okay. Alrighty. Here's hoping it doesn't blow up in my face. Hey, how about that? We even put it in the right direction. Very nice. I love it. Very, very cool. I think we're going to keep this guy around and do some experiments with it. You guys think that's cool? All right. So, that's a cool kit. Oh, hello. All right, try again. The Velleman K5300. My birthday present from Vim. Thank you, Vim. Thank you guys for watching. I hope you enjoyed this video. If you did, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all the patrons. Big thanks to you guys for watching. That's it. I'm out. Peace.